Hello everyone. Today's video tutorial has to do with buoyancy. Let's look at this really huge cruise ship, which we know weighs many tons. Why is this cruise ship able to float? Well, it has to do with buoyancy. The cruise ship has buoyancy. Buoyancy is the ability to float in a fluid. Remember, fluids can be liquids or gases. The force that causes buoyancy is called the buoyant force. All objects that are in a fluid, whether it's a liquid or a gas, have this buoyant force acting on them. And buoyant force works the opposite direction of gravity, so it makes objects feel lighter. Remember, you learned the difference between mass and weight weight is the downward force of gravity on an object. So an object's weight is how much gravity is pulling on it. Let's look at this ice cube floating in the glass of water. We have the buoyant force pushing upwards on the ice cube, and we have gravity pushing downward. Or another way to say it is that we have the weight of the object pushing downward. Going back to our cruise ship, even though gravity forces a ship downward, the water also exerts an upward force on the ship at the same time. So if you look at these two arrows that I've placed here, we have a larger arrow here, which represents a larger force. So we have a buoyant force here that is larger than the force of gravity pushing down on it. Let's go to another example. Here we have a cinder block placed in a container of water and a cinder block just sitting outside of the water. So which one is easier to pick up? Well, the one in the water is. Think about any examples of times when you were in a pool and you tried to lift someone else up, and how much easier they are to lift up when they're in the water than when they're outside of the water. What's the reason for this? Well, we have a buoyant force pushing upwards, which then negates some of the force that's pushing downward on the block. So we have an object that feels like it weighs less. When will objects float and when will they sink? An object is going to float in a fluid if the buoyant force is equal or greater than the object's weight. For example, a cork will float in water because its weight is less than the buoyant force that's pushing on it. And then an object's going to sink if the object's weight is greater than the buoyant force. Let's look at the two spheres here. We have a sphere on the left-hand beaker, that is floating, and that's because the buoyant force in this case and the weight of the object are equal. It could also be that the buoyant force is greater than its weight to make it float. And then on the right-hand side we have the marble, which has sunk because its weight is greater than its buoyant force. And so you can see that we have a net force here that pushes downward. Now you've noticed that buoyant force can vary. It's not always the same magnitude of force on every single object. So what determines or decides the amount of buoyant force that acts on an object? In order to answer that question, we have to go back a couple of thousand years to a Greek mathematician whose name is Archimedes. And Archimedes lived in the 200s BC, and he came up with a principle called, of course, Archimedes' principle. And what his principle says is that the buoyant force that's acting on an object in a fluid is equal to the weight of the fluid that the object displaces. Now that sounds really confusing. And so we're going to go to Bill Nye in order to help him to explain this. And then we're going to come back to this principle again.
Imagine this. Whenever a boat's in the water, it pushes some water out of the way. We say it displaces some water. See, displace, place away, you with me? So it's as though this model boat of science were making a hole in the water shaped like this. Now take a look. This is the aquarium of science, and it's filled right to the brim. As the boat settles in, it displaces some water. It runs over the rim, down this gutter, into this pitcher. Now the model boat of science displaced this water. In fact, all boats displace water. In fact, everything you put in the water displaces some water. Here, watch. This is the water level of the dunk tank of science. Watch. Using the latest in dunk tank technology, I'm going to displace some water. You ready? 3, 2, 1. Pretty cool, huh? I displaced some water, right? Just like the model boat of science. Now watch this. I'm going to place the boat on the scale, which right now is in balance. Now the boat takes it out of balance. Now I'm going to put the water that we displaced earlier on the other side. See? Just balance. Now, watch this. Take the displaced water, take the water, put it back in the hole we had earlier. That's one. Here's the second. It fits exactly. Isn't that cool?
Let's look at Archimedes' principle again. Bill Nye was showing us that the buoyant force that was keeping the object up and in the water was equal to the weight of the fluid that it displaced. Thinking back to his video, the model boat of science displaced a certain amount of water, and when he weighed that amount of water that was displaced, it was actually equal to the weight of the object itself. And I do apologize for my dogs. They're really excited right now. They see somebody out in the front yard, and I'm trying to keep them from barking too much, but I'm not having a whole lot of luck. Rico wants to know, well, doesn't density have something to do with whether something floats or sinks? Well, Rico, you are very right there. Let's take a quick look at what do we mean by density. In everyday words, density has to do with how crowded particles are. So the molecules and atoms, how close together or far apart they are. The less space between the particles, the more dense the object, because it's more tightly packed. And then the more space between them, the less dense it is. Let's look at something we are familiar with. Soda. Predict what will happen when I place a can of regular Coke and a can of Diet Coke into a container of water. What do you think they're going to do? Are they going to float or are they going to sink? Look at the picture on the left. The Coke sunk while the Diet Coke floated. I wonder why that is. Well, as we know, diet soda contains artificial sweetener, which actually has less mass than the sugar that regular soda has. And so we have more matter or stuff crammed into the same amount of space for the Coca-Cola. And so the mass of the regular Coke is higher than the mass of the Diet Coke. And so the Diet Coke has a density that is actually less than or equal to the density of the water. Now we call this relationship of mass to volume density. So density is mass divided by volume. So it is pretty much how much mass or matter do we have packed into a certain size or volume of the object. And the density of water is 1 gram per centimeter cubed. That means if you had a cube, a tiny, tiny cube of 1 centimeter by 1 centimeter by 1 centimeter in size, and you filled it with water, that would weigh 1 gram. That's what it means by the density of water being 1 gram per cubic centimeter or centimeter cubed. If the object has a higher density than the density of the fluid it's in, it will sink. And if it has a lower density than the fluid that it's in, then it will float. Let's look at this floating ship. This ship is made of steel, and if you look here, the volume of water displaced is represented by the purple shaded area. So here we have a large ship that has a large volume, and that volume of water being displaced is a large volume of water. Whereas if we had all of that steel placed into a tiny area, a tiny volume, then we have a smaller volume here, so we have a greater density, and so the object's going to sink. So the reason that this boat floats is because it has a certain weight, but that weight is pretty much spread out over a larger volume, and so it has less density than the density of water. Whereas here, the block is compact, and it has a greater density than water because it has the same amount of, but it has a smaller volume. Let's look at a beach ball. This beach ball is buoyant or floats because it has a lower density than water. So the buoyant force is greater and it floats. Here we have the cinder block again, and the cinder block has a higher density than water, and so that means it's going to sink. And if we have an object that has the same density as water, then its buoyant force is going to be equal to the weight of the boot. And so the boot is not going to sink or float. It's going to stay where it is. So if you placed it in the middle of a container of water, it would stay right where it is. If you placed it toward the top, it would stay where it was also. We could change the object's density by changing its mass or by changing its volume. Using our simple equation here, we can change the density here by either increasing or decreasing the mass, or by increasing or decreasing the volume, because that's going to end up with a different density calculation here. Let's look at this picture of a submarine. And submarines are able to change their density by taking water and air into the tanks that surround the submarine. So let's look here at this picture here. So when a submarine wants to dive, it takes water into this outside compartment here, which makes it heavier. So its weight is greater than the buoyant force, and so it's going to sink. It's going to dive. Looking at figure 2, if we want the submarine to stay right where it is, then we need to make sure that its density is the same density as the density of water. And then if we want to rise again, then we need to force some air into these tanks to push that water out, and that's going to make this way less, and so it's going to have less density, and it's going to make it rise. Let's look at a little interactive that shows you how submarines can rise and lower. And I think that'll kind of explain this a little better to you. Okay, so let's look at this submarine here. We have the water tanks that they're filling full of air so that it rises. And then they're filling it with water again so that it sinks. So they're changing the density of the submarine by changing its mass. The volume of the submarine never changes, right? Because it still takes up the same amount of space. But they're changing the volume by changing the mass of the submarine. So let's pull everything together. An object can float when its weight is less than the buoyant force, or it's less dense than the fluid it's in. And remember, we can make an object float by decreasing its mass, or we could also make it float by increasing its volume, making it take up more space than it did originally, and that could allow it to float. And an object can sink when its weight is greater than the buoyant force, or it's denser than the fluid it's in. And we can make it sink when it increases its mass and becomes denser than the fluid, or when it makes its volume smaller. and it becomes more dense than the fluid. That's the end of this video presentation. Please make sure that you have nice complete notes and have written a summary for your Cornell notes. Thank you. See ya.